asking about this question here. This was the practice on the bottom of the syllabus. And what we have is a velocity time graph given, and you have to give the acceleration time graph. And the easiest way of going about doing this is to realize that the slope of the velocity time graph is equal to the acceleration. So basically, if I just remember that.
You just calculate each and every point and then get the points.
Yeah, slope of v versus t graph equals the acceleration. So if I come over here, I see how the slope is constant here. It's the same slope all the way through. So I'll treat that as my first segment because I don't have to figure out the slope here and then figure out the slope there and then figure out, because the slope is the same all the way throughout. So I'm just going to find the slope of that first segment. And when I do it, I know that slope equals change in y over change in x. So slope equals, my change in y is going to be from 0 to 10. 0 meters per second to 10 meters per second. So it's going to be 10 meters per second minus 0 meters per second all over. My change in x is going to be from 0 seconds to 5 seconds. So 5 seconds minus 0 seconds. So when I find that slope, it turns out to be equal to 10 divided by 5, which is 2, and meters per second divided by second, which is meter per second squared. And it's a positive slope. So I know my slope right there is positive 2 meters per second squared. So my slope right here is positive 2 meters per second squared. Right there, it's 2 meters per second squared. And right here, it's 2 meters per second squared. So basically, I can make a graph here, and I think I'm going to put 0 in the middle here. That's for the time. And I'm going to say that this is 0 meters per second, and then maybe this right here is 1 meter per second, and then that right there is 2, and then down here that would be -1. And the reason I knew I had to go negative, because what's going to be the deal over here? It's going to be a negative slope, so it's going to be a negative acceleration. So that's why I knew I was going to have some negative down over here. So during A, from 0 to 5 seconds, what do I know my slope is? 2. Right there. 2. And then what about from, maybe I should keep that in red.
It is? Okay, because I just ran out of my extra help because I thought it was 3. Okay, alright.
Okay, now what about the slope from 5 to 15 seconds right there?
0.
So what's the acceleration during that whole span? 0. So from 5 to 15, it's going to be 0.
Do you have to do that drop thing?
Yeah.
So
And basically I have to connect the two. So when I connect the two, it's got to go from 2 to 5. Now, it's never perfectly vertical because you can't just instantaneously change, but for our sake, we could just drop a vertical line right there. And basically that's just saying, hey, within an instant of time, boom, it went from 2 meters per second to 0 meters per second. And then what about over here, segment C? Well, if I find the slope over there, the slope would be negative
One half.
1/2.
Yeah.
So it's going to be negative 1/2 right down there.
So you have to drop it, right?
And I have to drop it right there.
Oh.
So my whole answer would look like that.
So we're only gonna get an acceleration graph tomorrow?
You never know what you're going to get. You could get any of the three and be asked to find the other two. Now, in part B down here, they ask, calculate the position of the object at t equals 5 seconds. So,
You use that x equals.
You can use velocity. You can do v
Don't you just
equals x over t,
Or x
and you could
equals
do 10 equals x over 5.
Why can't you just use
Yeah.
the x equals
Yeah. Why don't you just do x equals
well,
v
I just
times-
want to point out, you have to be careful because you want to put in 10 meters per second right there. Is that what I hear you saying?
No.
Or no?
For
Don't we have to isolate
x
the variable?
over t.
Because we want to know during the 5 seconds right here,
Yeah.
during that 5 seconds right there, how far forward it went.
Yeah.
What-
Never
what
mind,
would you-
never mind, just erase it.
When was
Yeah.
the average velocity 10?
Yeah. We could use that formula,
We have to find the average velocity.
but you have to find the average velocity.
Okay.
Alright? And I actually like that formula. It's pretty common sensey. Like, look, if you started here, what's the velocity there? 0. And what's the velocity here? 10 meters per second. So if it went from 0 to 10 meters per second, what's the average velocity?
50.
5.
Whoopsie.
Oh, I mean,
It's 5.
close. The whatever is 50.
Whatchamacallit?
Is it 25?
It went from 0 to 10, and
No, I know the whole thing.
so that's going to be an average velocity of.
5, and then so 5 equals distance over.
So then over
5.
here, 5 meters per second equals distance over how much time?
5 seconds. So it'd be 25 meters.
X equals 25 meters. So that's one way of doing it. So your answer, hey, what's its position? Well, its position after 5 seconds would be 25 meters. But another way of doing it,
Oh, you needed average velocity, that's why.
that's what we did right here. We
You
get the
couldn't
average.
just have velocity.
Correct. The other way of doing it, which is very sophisticated, is to remember there's 2 key features on a graph that give like really important information. One of them is the slope of the line, and there's a second key feature that's very helpful. Area underneath the curve.
We go over that.
And basically, for this little segment right here, what did the slope tell us? The acceleration. But guess what the area underneath the curve right here is?
I don't know. The distance?
The forward displacement, yes. So if I find this area right there,
Okay, so that, that'd be 25.
that area right there is going to be 1/2 times base times height. With units though, 1/2. What's the base right here with units? 5 seconds times, what's the height with units?
10 meters per second.
10 meters per second. And if you crunch that out, what do you get for the area? 25 meters. And voila, you get the same answer. So that's the other way of finding. Question?
Find the
It's not on this problem. I just realized to go to my game, so can I just ask all the problems really fast?
Yeah, just hold your horses for 1 second, okay?